Hi there, Gershom. Welcome, Sino.
Welcome, everyone. We can welcome Alzan back. We've missed her, but she's back with us today. She's avoided the load shedding world, thank goodness.
Yes. Was I here? I was here Wednesday, wasn't I?
Okay. Were you?
I think I saw the grade 8s on Wednesday. It's a very good question.
It's just, for me, it blurs. The week just blurs.
Hi, Mokiti. Hi, Litando. Welcome, Mohammed. How are you guys today? Did you guys have a good weekend? Who would like to share what they did over the weekend?
Yeah, let's hear what you guys got up to. What did I do? I played tennis and I went to Brackenfell, which is far away, to see a friend. Made a braai. So that was nice. What did you guys do? Welcome, Lutando.
Hey, Mohammed, would you like to share with us what you did over the weekend?
It's more of just exams.
Oh, shame, yeah, of course.
Exams. Oh, what exams were you preparing for?
I already did NSRO math paper 1, which is algebra. Math paper 2 is geometry. I did what else? LO. Yeah, I think and English essays. Tomorrow I'm writing grade arts, and then Wednesday. And then like in 2 weeks time I'm writing math paper 2, which is geometry section.
Oh, brilliant. Well, today's lesson will be helpful because it's going to be around surface area, volume, paper 2 type things. So you're in the right place.
Yeah.
Well done for working hard over the weekend, Mohammed. Asonge, what did you do over the weekend?
Hello.
So, Ozan, if you haven't, I think you can switch on the live stream. I'm all good we can do that. Who else is in the chat?
Awesome.
Give us a thumbs up or something just to let us know that how you're feeling generally. You don't even have to jump on the mic. Aha, well, oh, fantastic. Okay.
And Asonge, if you'd like to share, then we'd still love to hear. Hey, I heard that hello.
Yes, Asonge, let us hear. What have you got to share?
Hello. What I've done during the weekend is I've been studying and played some basketball in the weekend.
Oh, nice.
Very
Awesome.
cool. Always good to stay active.
Very
Thanks
much.
for sharing.
Pleasure.
You got to exercise, hey? Like what I do is after I do this lesson, I go for a run. And today I'm actually going to go to gym after this. So, because you have to balance this sort of sitting and listening with the learning. It kind of all just works together. So
yes.
I think that's a really good habit of Sange. Okay. All right. Ozan, I'm ready to rock and roll. Anything from you before I go?
I just want to show you guys that we went hiking, and so this is the picture of the hike, and we slept in a cave the evening.
Oh,
so this is the picture of the cave that we slept in.
Wow. Is that near George and all around there? Or?
In George, yes, on Van Dalen's mountain, they call it. Very steep, but we survived. So I'm glad to be back with you guys today, still alive.
you get the points for the coolest
weekend. I know,
cool.
I can't complain. It was amazing. But guys, enjoy. I'll see you again afterwards. And yeah, have fun, Peter.
Thanks.
I'm here if there's anything. If you guys have any questions, feel free to just send it on the chat or unmute yourself.
Cool. All right, everyone. So in the last lesson, we spoke about area, and we spoke about the area of a couple of different shapes. And in the lesson before that, we spoke about perimeter, so fencing around a shape. Now today, I want to start with 2 do now questions, and I want to get a sense of how you guys are doing. And basically what you have to calculate is you have to calculate the surface area of this shape over here and this shape over here. Now, surface area, I call it like the wrapping paper quantity. It's like how much wrapping paper would you need if you perfectly colored around the outside of a shape? Now, obviously you are definitely going to need to know the formula for the area of a rectangle. Okay, so that's my one hint. The rest I want you to actually answer me. Okay, so I want to see what you can do. So question 1, you choose option from A to D, and question 2, an option from A to D. And then based on what I see in the answers, I'll take it from there.
Peter, it seems like you're lagging.
And can everybody see okay?
Yes, it seems like you're lagging a bit.
Am I? Okay, let me see if I can make this a bit bigger. How am I now, Ozan? Is it okay?
Yes, much
Okay.
better.
Okay, just shout, if it's messing around, just put it in the chat. I have got the chat window open. I can switch to mobile if the broadband is being funny.
Okay, cool.
All right, so everyone, are there any questions? Or give me a thumbs up if you understand the question. And we are basically extending our knowledge of area, and we're trying to work out if we had to cover this shape in wrapping paper, this outside area, we call it surface area because it's on the outside surface. How much area would you need? And we're given the dimensions of this rectangular prism. So the one dimension is 5, the other one is 4, the other one is 8. So I'm still not seeing any thumbs up yet. If you understand the question, just give me a thumbs up. If you need more explanation, give me a thumbs down. Okay, some questions, answers are coming in already. That's good. Get my calculator. Well, actually, I've got the answers on the right here, but just in case. Okay, so there's lots of interest in 1D. So the basic idea is that you get these pairs of rectangles. So the one way you can do this is you can say 2 times 5 times 4 for the 2 red ones. And then for the front one, it is going to be 8 times 4 times 2. In fact, actually, before I work, the answer is correct. It's 1D. So I'm actually not going to go for, it seems like everyone gets this question. So basically, you have to add up these pairs of rectangles. There's a couple of different formulas, but as long as you're getting D, that's all good. And then for the next one, it's a similar idea. So there's this rectangle on that side, and then on this side, and then those pairs. I see lots of things coming through, and I see most of us are giving a C, which is correct. Okay, I think for the most part, people have been okay on this. And so I'm going to move on because that was pretty well done. And you seem to have understood. So we'll move to more complicated shapes, but well done. Okay, so a bit of review. So the important 2-dimensional shapes are the triangle, the circle, and the rectangle. Okay, so those are things that we spoke about last time. And the formulas for the area of these things were like half base times the height. For the area of the circle, it was pi r squared. And then for the area of the rectangle was length times breadth. If we get any other shapes, for example, what we call compound shapes, we just break them up into pieces. So there may be like a piece for the rectangle, and we work that out, and then a piece for the triangle. And then we also talked about things like this. This was called a trapezium. There's a couple of different ways you can do this. There's its own dedicated formula, or you can chop it up into pieces. So that's the area part. Now, in today's lesson, we're going to talk about three-dimensional shapes, and we're going to talk about their surface area, which is the area, like the wrapping paper around the outside. And then we talk about the volume, which is how much we can fit in something. And so we just did a question now where we were dealing with something called a rectangular prism. But you also get things like this. What's this called? Let's see if my three-dimensional drawing skills are any good. What is this thing? I'll call it label A. What is that called? What sort of 3D shape is that? You can shout it out if you want.
Triangular prism.
Well done. It's a triangular prism. So when we calculate the surface area of a triangular prism, we have to find the front triangle and the back triangle. And then we also have to find the area of the rectangle facing us, the rectangle at the back, and we have to find the rectangle at the bottom. Okay, so the triangular prism is not quite as simple as, say, the rectangular prism, but it is doable. What do we call, excuse my funky drawings, but I'm trying my best here. What do we call this shape over here? We'll call this B. What do we call that shape?
Cylinder.
Well done. That is completely correct. Now, the cylinder's surface area is a bit more tricky because it is the two circles are easy, but what about the curved bit along the way? And so the best way to think of this is if you hold up an A4 piece of paper, I'm just going to get you a piece from my little notebook here. Can you guys all see the piece of paper? So I have here sort of like a what's this, like a telescope type thing, but it's a little bit like the body of a cylinder. If I unfold it, can you see it makes a rectangle? So the top bit over here is a circle, the back bit is a circle, and then when you unwrap it, it's a rectangle. Now, what is a little bit sneaky is what are the dimensions of each of these, what are these things over here? And what is this thing over here? So we've discussed that the formula for the area of a circle is pi r squared, and there's two of them, but I'd like someone to either put in the text or jump onto the microphone. What are each of these sides? Like, how do they get described when we're talking about a cylinder? Can anyone help me with that? So the main idea is, if you imagine unwrapping this bit around the outside here, this is going to be the height. So the one length is going to be the height. And then the bit on top here is going to be the other thing that you unfold. And this is called the circumference of the circle. So the circumference can be C, or as we discussed in the previous video, it's just diameter times pi. Now that is quite a sneaky thing to remember. And I always tell my students in class to go back to a piece of paper. And you can always see then that the one length of the rectangle is the circumference, and the other length is the height. And so if you want to find the surface area of a cylinder, you need to find two circles, which is just 2 pi r squared, and then the area of this rectangle over here. Okay, so those are the main shapes. There are some other variations, but that's just a little bit of a kind of top-up lesson up front. Are there any questions or comments that you'd like to ask? whilst I'm doing my little bit of teaching to you. Are there any other shapes that bug you that you want to bring up now? Okay. Then what we're going to do is we're going to play a little surface area Kahoot. So if you give me a second, I'm going to open it up. And then I will get you guys to come join me. And I'm just going to have to switch my screen. So let me find Zoom. Okay, stop share. And then share to that. And we'll bring it back to the side. And we are going to play. Okay, so again, this is just for me to get a feel of what you know. What you need to do is open up another tab, and once you have joined, you will see your name appear in the on the screen. Elzon, can you see the Kahoot thing? Is it showing?
Yes, I can see Kahoot.
Okay, fantastic. So you go to www.kahoot.it and you punch in the code 6608807 and you should see your name come up. This is a quick little.
So how do I get into it? Sorry.
So you go to www.kahoot.it. So if you can see the screen, I think it says W, yeah, and then the code is 6608807. So far, Asonga has made it into the Kahoot. Wande is here.
I can't see the code, sir.
Ah, okay. So you type www.kahoot, so KAHOOT.IT. So that's the address. And then the code is 6608807. And Alzon, if I could just ask you to put that in the chat so you can look at the chat window. There we go. So it's just going to be a short one. Welcome, Sino. I see you in the game. Okay, the code will stay up on the screen, so you can still join us. Don't worry if you haven't made it, but we're going to let the games begin. You have to calculate the surface area of that shape. And then if I ask you guys to mute your mics, if possible, one of you, I think, might have your mic on unmute. So think about the 2 triangles and the 3 rectangles is my hint to you. Give you a little bit more time, so 10, 15 more seconds, and then I'm going to call it a thing on this. Okay, 3, 2, 1. Okay, so let's have a quick look at the shape as to how we would get it. So the correct answer was 144. And what you should have done is I would have first started by doing the triangles. So you would have gone half times 6 times 4 to get the area of one triangle. And then you would times it by 2 to get the back one. Okay, and that's your 2 triangles taken care of. Then the one rectangle is going to be 2 times 12. The other rectangle is going to be 6 times 12. And then what do we have for the other rectangle? We've got a 4 here and we've got a 6 there. We have to use what's called the theorem of Pythagoras. So those of you who don't know about the theorem of Pythagoras, you would have used that to find the other side, and it would have been a 5. And so you would have got 5 times 12 for the other rectangle. Okay, I can't actually draw up the screen now, but we'll do another one similar to that. So you did have to do some working out along the way.
Peter, we have 2 learners that says that they're struggling to find the answers and the questions on their phone. They are on Kahoot.
Yes. Let me put them, okay. Let me do something now whilst I can change the let me just share desktop number 1 and then come on. I don't know if I can see it here. Does that help, Alzan? Having it like something like that?
So I can still see your full screen.
Yeah.
And there's a small screenshot on the side.
Okay. So I need
But
to.
I can only
Okay.
see your screen.
Okay. I tell you, we're not going to do this for too long. I just wanted to sort of test it out. Tell those learners we're going to come back now. Okay. 3, 2, and 1. Okay. So what I'm going to do is I'm actually going to go out of the Kahoot, and I'm just going to talk about these 2 questions and in the actual OneNote page. So let me come back to those. So I'm going to declare the game over. Apologies, everyone. Let's just do one more, and then we'll talk about these.
So currently, what should we see on the screen?
You should be seeing the Kahoot thing.
So I can see your desktop, and
Oh,
then
you're not seeing the right. How about that?
Yes, perfect.
Thanks. Sorry, I had too many things open.
No problem.
Because what I'm going to do is I'm actually going to talk about these questions now in a moment. Okay. I'm gonna give you 3 more seconds, and then I'm gonna work through these together. Okay. So I can see that this is causing some trouble for you guys, and so that's the point of being here. So let me just close all these things, and then I'm going to move back into OneNote, and we are going to talk about how to handle these. Okay. Where is OneNote? No, I've lost that. Okay. Ozan, can you see OneNote now? Can you see like a picture warm up?
Yeah.
Okay. So I'm just going to put, here are two of these questions that we spoke about. And I'm going to spend some time now with my pen talking about how to find them because I think they were causing some trouble. So give me a thumbs up if you can see the board nice and clearly and you're ready to kind of listen and learn about how to do, we're going to find the surface area of these two shapes. So give me a thumbs up or some indication that you can see the board clearly and you're ready to listen. Okay. Let's do this one over here first. So this one over here is a rectangular prism, and we have pairs of rectangles we need to deal with. So let's deal with the bottom one first. And that bottom one has a matching one on top over here. Now, there are different formulas you can use, but for now, I'm just going to say 2 times 13 times 6. And that is going to be the white rectangles taken care of. Now, the green rectangles are going to be that one over there and that one over there. But I need to figure out what the dimensions are. So this is going to be 6, and that's going to be 7. So I go plus 2 times 7 times 6. Okay, what are the only ones we have left? The only ones we have left is this back one over here, and then it's got its own matching front one. And those dimensions are going to be plus 2 times 13 times 7. So whenever you have a rectangular prism, you're going to have 6 sides, which is why you have these 3 pairs. And so the answer for this should be 2 times 13 times 6 plus 2 times 7 times 6 plus 2 times 13 times 7. We should get 422 inches squared. Okay, so that is the rectangular prism. Can you give me a thumbs up if that was clear? Give me a thumbs down if you're feeling still very confused. I'll wait a moment, or you can jump online and say, no, sir, things are going well, or sir, ish, things not going so well.
So for is this for perimeter? Do you just add them all up and then for area?
Yeah. So for area, for surface area, I call it the wrapping paper. So all I'm doing is I'm finding the area of each individual rectangle. So for example, the first one I did, I think I did 13 times 6. That was this bottom one here. But then instead of counting it individually, I realized that above this, there's another one just like that. And that's why I'm doubling over here in this part here. And then I just repeated that process. I always double because of the fact that it occurs in these pairs of 2 with the rectangular prism. Does that kind of make sense?
Yeah.
So I'm basically just, now there are other formulas that teachers use sometimes, but I'm keeping it like so that we can really understand what's going on as best we can. Now, the same idea applies in the second question, except it's no longer just 6 faces. How many faces do I have to deal with in the second one? When faces, I mean kind of like the 2D shapes on the outside. How many faces do I have for question 2? I'd like everyone to put in the chat. How many faces do I have to deal with? Okay, Titako, you are on form. Indeed, it's 5. It is 3 rectangles and it is 2 congruent triangles. Now, what do I mean by congruent? I mean they're exactly the same. Now, we may have to use a theorem called the theorem of Pythagoras, which we covered in a previous unit, but I'll give you a little bit of a warm-up in case you've forgotten. So let's go for the triangles first. And let me draw this nice and big. So for the triangles, I'm going to go 1/2 times by 3. Now, the 3 that I'm talking about is over here, times by 2, which is this thing over here. But then I'm not done. I'm going to times it by 2 one more time, because there's a triangle that's directly behind as well. So this one and this one are matching. So what do we get for that? 2 times 2 is 4, times 3 is 12, times half is 6. So we know that the two triangles areas are 6 yards squared. Now, yards is just another type of measurement. But we haven't found this full surface area now. What we need to do is we still need to find the area of the rectangles. Now, if we look at the area of the rectangles, you'll notice that there's a 5 over here, which may be quite helpful, because we can say, well, the area of that rectangle, okay, I should just make sure I know where this is, that 5 is attaching to. I'm assuming the 5 is attaching to this. If it doesn't attach to this, then we've got problems. So if that is the case, 5 times 10 gives me the area of that rectangle. Now, I think this question is being a bit sneaky, but basically it's kind of implied that this is the same as this, but it should really have put a little arrow over there. So another one will be, the one on the other side will also be plus 5 times 10. If you're feeling a bit unsure about that, I totally understand why, because the question was a bit vague in that way. But basically, we're saying that one over there is the same. And then the last rectangle at the bottom is going to be, what do you think it's going to be? Type it in the chat. What do you think the area of this rectangle at the bottom is going to be? So it looks to me like this is 3, and that's 10. So we'll say 3 times 10. So in total, we have 50 for that one, 50 for that one, 30 for that. So we get 130 for those ones. And together, it would be 136 yards squared. Okay. So that gives us a sense of how we would calculate that. So I'm going to move back to the actual lesson now, or not the lesson, but I'm going to go back to sort of questioning you. Are there any more questions before I do that? Is that a question? Comment? Anyone? Okay. I want you.
Sir,
hi. Yeah?
Hello? I'm lost actually.
Okay, you lost. I'm going to let everybody try and do this next one. And while we do that, I'm going to talk about the question on the board. Okay. So we're going to do this one together. Let me just quickly get my eraser. Is it working? No. So large eraser. Oh, it's not working. Okay. Everyone, those who are feeling comfortable, if you could please try, oh, this is about volume. Okay, this is a volume question, so maybe I should actually move on to a question which is about surface area. Okay, now let's rather do surface area. I want you to try and calculate the answer to these two questions. What is the surface area of these two questions? And what I'm going to suggest is, for those who would like a bit more feedback, I want you to put in the chat, how many faces are there on this first drawing? So if you look at this first one, if you count the faces, there's 1 face, there's 2 faces, there's 3. How many faces are there in this first shape? Because that will help you unpack it. Okay, I see some answers coming through. You get 6 faces. Now, how big is each face? In this case, each face is a square. So we need to know what is the area of a square. It's just going to be side times side, so 10 times 10. So this one over here its surface area is going to be 600 centimeters squared. Now, if we go to question 2, I want you to think again, how many faces are there? And then I want you to try and calculate what the surface area of this rectangular prism is. Now, the person who was having a bit of trouble, could you give me a sense of where you're battling? Is it knowing the method, or maybe if you could just fill me in where you're struggling?
It's more of the formula.
The formula, okay. So there's different formulas to use. Some people, I think the most reliable way to do this is to think how many faces are there and then count them in sort of combinations. Now, in a cube, there's 6 faces. It's also 6 faces in this, but I always think about counting pairs of rectangles. So the method you're going to use, I'm going to suggest, is pairs of rectangles. There should be 3 different types of rectangles, and you need to find the area of one of them and then double it. Does that help? Let's do the first one together. The first one's area is going to be 8 times 5. Now, if I stop at just that, I won't have got both rectangles. So what I'm going to do is I'm going to times that by 2. Now, that isn't the surface area for the whole shape. That is just the surface area for the rectangles that are red and colored in. But what about this rectangle at the top and at the bottom? How am I going to calculate the area of those 2 rectangles? Well, I'm going to go 12 times 8 for one of them. And then because there's 2, I'm going to double it. But I'm still not even done, because there's still rectangles that are facing me and now at the back. How big are they going to be? Well, it looks to me like it's 5 tall and 12 across. So plus 5 times 12. And then I double it because there's 2 of these. And then obviously I need to use my calculator. So I would go, this is 40, so that's 80. This over here is, I suppose I can just use my calculator. So 80 plus 12 times 8.
80 plus 12 is 92.
Did you guys hear that? That was Siri jumping in. 12 times 8 times 2 plus 80 plus.
I didn't get that. Could you try again?
I'm going to turn that off. Okay, the answer is 392. So 392 centimeters squared. Okay, guys. So we're just basically working in faces, and then we're working where there are things that are doubled. We double them as we go. Let's do another one of these surface areas. Let me zoom in as well. Can you find me the surface area for these 2 shapes? Using, this is kind of, if you can do these, you've got pretty good. So I think this is going to be the last ones, or we'll do one on cylinders as well. See if you can work out these 2. I'll give you some time, and I'm going to get some water. Now, how many faces are there in this one? And I'll do some nice coloring in to help you. So I'm going to call it the blue rectangles. And then I'll call it the green ones. And then we'll worry about Looks a little bit rubbish. Now those ones. So that's my tip for number 3. And once you have your answers, you can pop them into the chat. So for 3 and 4. But you'll need a bit more time, I know that. So we have 100 for this long bit times by 25 times by 2, because there's 2 of them. And this bit is also going to be 25 times 100 times 2. So we should. What are the answers we have coming through? Aha, I see some answers there. I'll give you a little bit more time. It is indeed, guys, 11,250 millimeters squared. So remember, we must give the units to indicate that there are lots of little, there's 11,250 little millimeter squares that would fit around the outside of the shape. So that is correct. Well done. Now, what about the triangular prism? Can we do that? And then what do we have? So we have, that's 70, and that is 50. So 70 times 50. And then what is this going to be? Okay, I see some things coming through. You're on the right track. So let me just think. So you've got triangles there. You've got your height, which is 40. You've got that as 70. Now we're going to have to work out. We've got that 40. Oh, okay. This is the Pythagoras sneaky bit again. Okay. If this is 30, this little bit over here, if that bit is 30, and this tall bit here is 40, this is a right angle triangle, which means this thing over here must be 50. So in fact, let me use a different color because this called us out before. What I'm saying is, by the theorem of Pythagoras, when you have a right angle triangle, the sum of the squares of the other two sides is equal to the square of the hypotenuse. So we've worked this out using the theorem of Pythagoras. Now, if you're unsure about what that theorem is, we did a whole series on that you can have a look at on YouTube. And you don't have to watch long, you'll just have to watch maybe a couple of minutes of it. But I'm not going to go into detail about that now. Now, what that means is that...
Could you also say that the opposite sides of a rectangle are equal, so that...
Oh, flip, yeah. I just realized that. Hold on. So I actually didn't spot that. This 50 over here is the same as that 50 over there. So you spot on. So actually you don't have to use, you could use Pythagoras, But what I do want to point out is, can you see that these two green rectangles are identical? They're both going to be 70 by 50. So I'm just going to double them to count them twice. And now the question about the bottom rectangle is important. And that is going to be, the one side is going to be 60. Now, what is the other bit going to be? Let's have a look here. I've got too much clutter on my thing. It's going to have to be, let me think about that. Well, that's 60. And how long is it? That's going to have to be 70. So it's going to be 60 times 70. Okay, so what is the final answer going to be? Let's add this up. So a half times 60 times 40 times 2 gives me 2,400 plus 70 times 50 times 2 plus 60 times 70, 13,600. That's what I get. 13,600 millimeters squared. Okay, that was a bit of a tricky one. Okay, well done. You guys are doing well here. I can see that the growth is happening. I'm going to leave that one out for now. I'm actually going to make up my own little question about a cylinder. So I'm going to give you a cylinder. And I'm going to take the cylinder, and all I'm going to give you is I'm going to give you its radius, and its radius is going to be 10 centimeters. And its height is going to be 30 centimeters. Find me the surface area of this cylinder. I know it's not the nicest, prettiest looking cylinder, but I'd really like you to try and work out the surface area of this cylinder using what you knew from the previous lesson and using what you've learned today. And I'll give you this tip to help you out. It looks a bit like an old car or something smiling at you. So I want you to break it up into pieces. And I want you to think, how could I find the area of this one? How is it related to this one? And then I want you to think about this rectangle over here. I see some answers coming through. Now, there will be a little bit of difference in our answers because of something called pi. So that's fine. We will allow a bit of rounding differences. Okay, so for my first circle, the area is pi r squared. So pi times r, which is 10, and that's squared. But because there's two circles, I need to double that. So that's the one part. Now I need to worry about this rectangle over here. Now, if I unfold it, the height is going to be the one branch, and the circumference, I'll get the blue, is going to be the other part of the rectangle. Now we have to remember how we find the circumference of the circle. We just go, to find the circumference, we go diameter times pi. Now we don't have the diameter, but we do have the radius, and the diameter is just double the radius. So it'll be 20 centimeters. And so then the circumference will be 20 times pi. Okay, so now 20 times pi, or 20 pi, sometimes how we say, is that bit there. So I'll say here 20 pi. So to find the area of the rectangle, I'm going to go height was 30 and then times 20 pi. And so now I need to add these all together. Now, if I will use pi as 3,14, but you can use, actually, no, I'll use the calculator exact version, but times 100 times 2 is that, plus 30 times 20 times pi. I get 2,513.27. So 2513.27 centimeters squared. Okay, and I see a lot of answers along that way. If you are feeling unsure, don't worry. You just keep practicing. But we've covered the major shapes and surface area. So I just want to spend the last 5 minutes talking a little bit about something called volume, which is much easier than surface area. So the surface area, I've spent most of the time today on it because it was the harder of the two things. But when we move to volume, volume actually is really simple. And I'll give you an example why. So if I look at this shape, the volume is just how much stuff fits inside of it. And so basically, if I think of question A, it's just how big is the circle? And then once I've got that area, I times it by how deep that circle is. So the first one I will do with you, and I will just say, well, to find the area of a circle, I go pi r squared, where r is 5 in this question. So that's the blue bit. But then I want to know how many circles are stacked deep. And so I times it by 15. And so the volume is just going to be 25 times pi times 15. And I get 1178 point, if I round up, it's going to be 0.10 centimeters cubed. Now the units of volume, okay, I see the hard area question for tomorrow. Okay, I see we'll finish with the hard question there on one day. Okay, so can I ask you guys, I'm going to bring another question up. I want most of us are going to be doing the surface area question over here, B. It's not surface area, volume. I want you to find the volume of B. But for those who are feeling like they've got this completely under control, can I ask you to do, I'm going to add a harder question for you guys. So if you are feeling like you need more of a challenge, I want you to try and do this one over here. Okay, so we'll call this question number C. And so you wanted, okay, I tell you what, for C, I want you to find the volume and I want you to find the surface area, I wonder. Okay. So just to revise what we're going to finish with these two questions. Everyone is trying to find the volume of this cylinder over here straight away. And then for those who feel like, okay, I've got this mastered, you are going to try and find the volume and the surface area of this compound shape over here. And that's the last things we're going to do for today. Okay. So for B, to find the volume of B, it's going to be pi, so R, so 3 squared times 12. And so the answer for that one should be 9 times pi times 12. And so the volume of B is going to be 339.29 centimeters cubed. Okay, so let's all finish with this challenge question. We are going to work out the surface area and the volume of this shape C. And I see 339 in the chat, so it seems like we agree. So everyone's brains are going to this last question. And if you are feeling a bit overwhelmed by it, don't worry. I have deliberately taken it up a notch now. Okay, so if we wanted to do the volume, we're going to have a cylinder, and we're going to have a rectangular prism. So you have to find those two pieces. So we know the radius is going to be 4. And so pi r squared times 10 for the cylinder plus it's going to be 2 times 20 times 16 plus 2 times 16 times 30 plus where's the one? 20 by 16, 16 by 30 plus 2 times 20 times 30. Let's see what the answer is. 16 pi times 10 plus 2 times 20 times 16. 2 times 16 times 30. I get 3,000. Oh, wait, so for this bit, I get 3,302.65. So why don't we get, I wonder, we are differing here. So 2 times 20 times 16, let's just check again. 16 plus 30 plus 2. So that's 2,800 for that bit, plus 16 times pi times 10. 3,302.65. So I wonder, I get a different volume to you. So just check that. See if you agree with my working out. Now, how much time have we got left? Okay. I don't want to, the surface area part is quite tough because you have to subtract, but I'll give you some basic. Oh, I see what I've done wrong. Sorry, I've worked out surface area when I should have been working out volume. Hey. So I'll keep that there. My apologies. I've mixed the two together. I think that's what you're going to say there. So volume is pi 4 squared times 10 plus it's just going to be 20 times 16 times 30. 20 times 16 times 30. Let's just see if that gets us to the same answer. Plus 16 pi times 10. And I get 10,102. So you are quite right there, 10,102 centimeters cubed. Thank you very much, my diligent students. Now, the good news is I've done some of the hard work already for this one over here.
Sir.
Yeah. Question?
Sir, I wanted to ask a question. On the diameter of the circle,
Yes.
you have to write the half of it.
Yes.
Isn't it? Oh, thank you.
Yeah. So if you've got the diameter and you want to work out the radius, you simply have to halve it. Yeah, that relationship always holds. Okay, we're running out of time, but what I'm going to do is I'm not going to give you the exact thing, but I'm going to show you what you need to do. Okay. In this compound shape, you need to work out only the area of this top circle here. Okay. So this top circle is going to be pi r squared, so pi 4 squared, and I'm only going to do it once because surface area is left uncovered, so I only need one circle. Then what I need is I need to find the area of the bit going around the outside, and that is going to be the circumference, which is diameter, so times pi, times the height. So diameter times pi times the height. So that is going to give me those two. Now I'm going to add the bit that I worked out for the surface area of earlier on when I worked this out. But there's one last thing I have to do. What do I have to do to finish this off? This is a properly hard question. What have I left out? So I've got the red bit at the top. I've got the blue bit going around the side. I've got the green bit. But what is this thing doing over here? What's it covering? Anyone? So it's covering a circle. And so we actually are going to have to subtract a circle. So even though we added the top one, we're covering up an equivalent area over there. And so you're going to go minus pi 4 squared. And that is going to cancel out this bit over here. And so your final answer is just going to be adding these two things together. Okay, that was the tricky bit. That was the hard part, that you had to subtract the area that was hiding at the bottom. Okay, it's now 6 o'clock and I've probably gone a little bit over my time. So I'm going to hand back to Alzan. I hope that was somewhat helpful. And Alzan, thank you for granting me that extra time. I'm going to hand back to you now. We ran a bit longer today.
No problem, Peter.
Okay.
As long as the learners got their answers. I'd love to see how you guys are feeling. Send some emojis so that we can see where you guys are at. And while you guys share your emojis, I'm going to share my screen. So let's see, is there anything yet? How are you guys feeling?
I think they're still recovering from the last question. I think.
Thanks for your honesty, Gershom.
Alwande wanted a hard question because he's writing his exam tomorrow. And so I took it up a notch, but I might have left a few. Don't worry if you that last question was very tough. Please don't be too scared.
Well, just see this as an opportunity to overcome this challenge. So if this is something that you feel you struggle with, then you guys can just hop onto the Watobe app, go and find whatever resources you need to get the answer to the question.
Mokete, in the actual Watobe app, there is a section on surface area and volume. And what I would do is I would go and practice that. It's unlikely that you would need to know a question as hard as the last one, but at the same to do reasonably okay. But you do need to know the basics of finding surface area and volume with the normal shapes. And so you need to then go to and there's another lesson we'll do on Wednesday, and then we'll have a nice quiz at the beginning. Okay.
Okay. So let me show you guys. This is what Peter spoke about, surface area and volume. So you just hop onto the Watobe app, then you go in here.
Yeah.
And then you'll see here's all the different forms that you guys can look at.
Pause for a second. So especially now, triangular prisms. Can you see how today triangular prisms were quite a tough part of today, and the cylinder? So what you would go is you would go to that area that you feel a little bit like, we've sort of scratched an itch. We've showed you where you're weak, but now the idea is that you go and train, and then we come back on Wednesday and we see what difference that makes. Okay.
Okay, so you guys heard Peter. Go onto the app, go and find the topic that you want to strengthen your understanding in. And then when we get back again on Wednesday, we'd love to get some feedback on how it went. And if you have any questions, feel free to come with your questions as well. Okay, we're here to support you as much as we can, but we know the hard work pays off when we put some time in to understand it. Okay. So thanks so much, guys, for hopping on again today, and we will hopefully see you all again on Wednesday.
Cool. Thanks, Ozan. Thanks, everyone.
Thanks, Peter. Take care, guys. Bye-bye.
Bye, man. Bye-bye.
Bye. Awesome, Uketsi. Bye, Kuketso.